Hello everyone, welcome to Getting Started with Hadoop Ecosystem Core Components course. We are going to start with module 4, which is all about MapReduce practical programs, and we will learn partitioner and combiner concepts. So why we are learning MapReduce, partitioner and combiner? So we will see partitioner and combiner will add some extra features to our classic MapReduce algorithm so that partitioner, which is also known as customized shuffler, and combiner, which is also known as local reducer, that will help us to analyze the big data in much faster and efficient manner. So about OdinSchool. OdinSchool is a technology upskilling platform. We help you continuously acquire new skills. So stay skilled, stay ahead. Talking about myself, my name is Tushar Kakaya. I'm having 8 plus years of IT experience working with various forms of data. My main skill set includes Microsoft Business Intelligence, Hadoop ecosystem components, big data analytics using Apache Spark. I have worked with various tools like Cloudera, SQL Server Management Studio, and my main domain expertise lies in telecommunication domain. So, agenda for today's module, we will try to implement that classic word count problem using Java MapReduce, which we have already understood in our last module. In the last module, we saw what the algorithm tells, but in this particular module, we will try to implement the same on Cloudera machine using Java as a programming language. We will try to understand partitioner concept in MapReduce, combiner concept in MapReduce, and we will also implement that classic word count problem using partitioner and combiner concept again in Cloudera machine using Java as a programming language. So let us understand that classic MapReduce algorithm once again and quickly revise what we have seen in our last module. So we are having basically four phases of the entire process, which is nothing but splitting, mapping, shuffling, and reducing. In the splitting, we are split the file which we have got, for which we have to find number of occurrence for the word, which is what we are solving today, word count. So it will split that entire file to number of lines, and those lines along with their position would be input to the mapper. So mapper would again have a business logic. In our business logic, it says like we are having a line. We will divide that line into number of words, and for every word we will assign a static value 1. If you see, this was what we have seen in our last module, and this way all the lines would be given to different mappers. Then comes the shuffling and sorting phase, which would be automatically done by the framework, where different keys would be come together, and then same or similar keys would be clubbed together along with their same values, and they would be sorted. Like here you can see like deer is appearing twice, so this deer is actually clubbed together, car is clubbed together, bear is clubbed together, river is clubbed together. But then it is alphabetically wise sorted based on the key. So B comes first, then C, then D, and then R. And finally, the reduce function will perform the aggregation where similar key would be clubbed together and some aggregate function. In this case, we will apply that sum function on the values. So where 1 plus 1, which is 2, then 1 plus 1 plus 1, which is 3 for car, then deer for 1 plus 1 equals to 2, and river will have again a value 2. And this is what our output is, which we will write to any HDFS file. So this is our classic word count problem which we are going to solve. So for this problem we will consider for this particular input data which is there at HDFS, and the final output should be look something like this. So how we will solve that? Let us see that. We are going to So we are going to implement this word count using Java as a programming language. And in this particular demo, you would need Eclipse. Eclipse is a IDE, integration development environment, which will allow you to write down your classes for Java. Basically, it will give you a very nice user interface so that you can write down your classes. You can implement your code using different methods and all. And then it will also allow you to export your code to a jar file. Jar file is nothing but a file which you can run anywhere. Based on your build, you can prepare a jar file, and that jar file will help you to run your code onto the Hadoop cluster, and you will get the output to HDFS. So the very first step is write down your code, build and deploy to a jar file. And then you can actually use this particular command, Hadoop space jar path, and then space input file path. Input file path means nothing but from where you are reading the data for that word count. Okay, like this deer, bear, river, that file was there, right? So that file's path. And output file path means the output folder where you want to dump the output file. Okay, so at high level, if you guys see, then these are the parameters which would be provided by user in that implementation, where you will provide the job configuration like job name. Okay, then input format means it can have right now we are having text input format, but in future you can have images, right? So that can be having a sequential format, or it can have a POC file format. Anything can be there, right? JSON file format. So input format, input location where your input file resides, then map function which you will write, right? And in the map function, you always, if you see map function, you will always have some business logic which would be written inside the map function. Number of reduce tasks, that also you can provide. Reduce function where you will write down the aggregation logic, right? Then output key type means whatever output you are going to get, what should be the output key value type, right? So that also you have to specify. Output format, right now we are having text input format, and we want output also in text output format. So that would be text for us, but it can vary different program by program. Then you can also specify the output location. So these are the provided by user parameter. And if you see, Hadoop framework also manages many things transparently, which are not known to user. Okay, but as a developer, we have to understand what is happening behind the scene. Okay, so we are not going to skip that part also. We are not going to focus only on the writing the program using Java, but we will also see what happens behind the scene. So behind the scene, I have already told you, input splitting, that file input format split operation distribution happens automatically by framework. Then it will also invoke the map task. Okay, it will also start the individual map task. It will also do that shuffling, partitioning, sorting per map output. That would also be done by framework itself. And it will do some merge sort also. Merge sort means nothing but again a shuffling and sorting operation, which we have seen they have divided into these two part. Okay, shuffling, partitioning or sort per map output. And then for entire mapper output, it will try to do merge sort for each reduced task now. Okay, and then it will start individual reduced task, and then collection of final output would be there on HDFS. So all these things would be done by the framework. As a programmer, your duty is just to write the map function, reduce function, and the job conf file, which would be kind of a main method, where you will specify number of parameters like input format, input location, then which would be your mapper class, which would be your reducer class. All those things you can provide. We will see those things in detail, but at a high level, these all things are happening in your implementation for the word count. So without further delay, let us start implementing this word count problem in Eclipse. Okay, we will try to write the classes in Eclipse, and then we will deploy the jar file, and we will run whether we are getting the correct output or not. So let us get started. Okay, So I'm having this Cloudera Quick Start VM 5.12 machine, which we have already seen our HDFS module. I'm using the same machine. Inside that machine, I'm having Eclipse already installed. If you're not having Eclipse into any Cloudera machine which you are using, you can also download Eclipse from their direct website, and then you can write down the code in Eclipse. Any version of Eclipse should be fine, but I'm recommending that you should at least use this particular one, which is Luna version or above that, because it will support you the MapReduce work, okay, or Hadoop related stuff. So basically, I'm going to create a new project, a new Java project over here. I will try to explain you step by step what actually we are doing. Okay, we will create a Java project. I'm giving name like MapReduce word count demo, and you can see it will store at default location, which is root home Cloudera workspace MapReduce word count demo. That would be the folder name inside which we will be having all our classes and all. So do a next, and this would be the folder structure. There would be a src package or folder automatically get created and finish. And now if you expand to this, then you can see like src folder is there, and there are some jre system library, and you can see it is using Java SE 1.7 by default, because that is what this particular Eclipse is supporting. If you want to upgrade or downgrade the Java version, you have to specify using the build path and then configure build path. Here if you see, some Java compiler is there, and you can actually specify based on which JDK compliance you want to compile your build path or jar file, that you can specify. But right now I'm not going to change that, because if you see my machine, then if on the terminal I type java hyphen version, it is already having 1.7 version. But if your Hadoop cluster is running on 1.8 version, then your Eclipse should be set with a compliance 1.8 over here, because ultimately you are going to run the jar file which is built by this particular Eclipse tool to that cluster only, right? So cluster supported Java version should be specified in the JDK compliance. That is must. Otherwise, your compilation or build can be failed, and you won't see the correct output when you are running the MapReduce job. Okay, so you just need to ensure, you just need to see which version on is there on your cluster, and the same version you have to specify in the properties for that particular project in the JDK compliance settings. Okay, I will just cancel it out. Then you can see there are some jar files already included as a system library, but we are going to write down a Hadoop MapReduce program. So it has to interact with HDFS, it has to interact with that MapReduce, okay, Hadoop ecosystem. So to interact with them, we have to actually specify some external jar files, okay, which it has to bridge between like Eclipse and that Hadoop ecosystem. So these are the jars which we need to add, and the jar files I'm going to add from root. Okay, if you see the path, it would be root. Inside root you will be having a usr folder. Inside that you will be having a lib folder. Inside that, if you see, there is a folder called Hadoop. Inside Hadoop there are some common jar files which we need to select. Hadoop common.jar, then 2.6.0 cdh 5.12 jar. Then these are the jars basically which we will include. Press OK. These are the jars which would be required for some classes which we are going to define. Okay, then we will again add some external jars for MapReduce. For MapReduce, if you go to Hadoop 0.20 MapReduce folder, then there are some jar files, and you just need to select all of them, because we may use some features from this jar file. We may use some classes to import some functionality. Okay, so these are the dependency jar files, you can say, that you need to actually add as external jars in the configure build path option. Okay, Java build path option in the libraries section, add external jars, and you just need to select those jar files. Press OK, and you can see them in the referenced library folder. So these are the referenced library, which are included in this particular project. So whenever we will be writing the program, at that time you will not get any sort of errors. Basically, that is what use for this sort of reference libraries, because you can reference, you can take those reference libraries and you can import the classes from them. You can actually use some functions from them, some methods from them, interface from them, and that is what we are going to do. Okay, now right click to this project. We are going to create a package. Package is nothing but, if you are familiar with Java, you know, right? Like package is nothing but a placeholder where your relevant classes would be there. So I'm going to create a package named test mr demo. And if you just click on finish, you will be having a test mr demo package inside the src. So inside this package I'm going to create a Java class, and I will give this class name as word count. Okay, and this would be a public class. You can specify the modifier over here. It is belonging to this test mr demo package. You can also change this one, but we want in this package only. It is actually of superclass of java.lang.object. That is also fine. We can simply press finish over here, and it will give you a placeholder inside this word count.java file. So whatever is the class name, .java extension file would be created, inside this testmr demo folder. So word count.java is a particular file. Okay, and inside this there is a class named word count. So class name and this file name is same. Okay, now I just need to write down some import statements which we are going to use. The very first one which we are going to use is some, in case some IO exception is coming on, then you have to specify the exceptions. So I'm going to use IO exception package, java.io.io exception. Okay, that is fine. Then now basically in the word count class, we are going to write down three methods. If you see, the very first one, actually at high level, if I just explain it to you, at a high level, any particular MapReduce program, it will have three things. First is the driver class, second one is the mapper class, and third one would be reducer class. So this driver class will always contain main method, this mapper class will contain map method, and the reducer class will contain reduce method. So in the main method, we will basically define job configuration related things, and which is our mapper class, which is our reducer class. Basically, this mapper class can be named anything, right? And you can actually separate out all these things. Like your driver class is there in one .java file. Then your mapper class can be again with another Java file, and reducer class can also be there with another Java file. So basically separate Java files can be defined. Okay, and then you can take reference in the driver class for those separate Java files. Otherwise, in the same driver class, you can define the map class and reducer class. That is also fine. That way you will be having a single .java file. Okay, and that is what we are going to do over here. So if you see, public class word count, I will be actually writing the map class over here inside this file only. Okay, so it will be a public static class. I am defining a class which is named as map, which should extends MapReduce base. So you know it has to um, extend means inheritance, right? So it has to inherit this MapReduce base class. And if you just see, it has actually imported some package org apache hadoop mapreduce base. Okay, so that is completely fine. It has to extend to MapReduce base. At the same time, it has to implement the mapper interface. Okay, now mapper interface, this is a standard signature for any map class. A map class should extend to MapReduce base, and it has to implement the mapper interface. In the interface, actually you have to give key value types. Okay, let me explain it to you. So if you see the word count problem, then the mapper, let us say this is a mapper. Something is coming as input and something is going as a output, right? Now if you see, the input would be, if you remember, the input would be some input will also be a key value pair, right? So let us say this is your three key value pairs are there. The first one is nothing but the byte address, right? So let us say it is starting with 1, and then your entire line like deer, uh, river, bear, all these things. Then let us say 55 is nothing but your, again the next line is starting with 55, 55th character, right? And then your actual line. So that is way, if you see this as a key value pair, then key is always kind of a integer, right? And value is what you can say, it is nothing but some sort of text, right? In Hadoop language we are having some int data type, text data types. Okay, so key, if you see key, then it would be always some address or some location, right, from where the actual line starts in your file. Okay, so if we go by that route, in the big data it can happen, right? Like the character number of characters can be so large, so that your key would be increased, or key can be of beyond integer. So in Hadoop it is supporting some sort of long writable or long data type, if you see. Okay, right, like int greater than int, we are having a long data type. So long writable is some sort of a data type in Hadoop, and that would be your key data type. Okay, key, or I should say input key data type. Input key data type would be long writable. Now input value data type, we have to also define that as well. So input value data type would be nothing but text, because you can see clearly over here, right? The value is what you are getting as a text. Now if we talk about output, then in output what will happen, the mapper output would be something like this, like deer comma 1, bear comma 1. That means now if you see, the output key is actually text data type, and output value is always a static one, which is a int data type. It will not go beyond int, right? So you can actually see or specify output key data type would be text, and output value data type would be int, something like this. So this would define your interface signature. The interface which we will be writing, the mapper interface, it has to take the input key data type, input value data type, output key data type, and output value data type. And that is what we are going to specify over here. So you have to calculate this kind of thing. You have to imagine what would be your input key data type, output key data type. So that way you have to form your classic program then in this key value pair. Okay, it's all about key value pairs. You have to transform your program into key value pair. Okay, so in the mapper you can write down long writable. Okay, then text, then next one is output key data type, which is text, and int writable. And then you will be starting with your actual map class. Okay, we are getting some sort of error over here. You have to simply import this mapper interface, which is org apache hadoop MapRead. Let us just import this one. Okay, and for these data types we can actually import this long writable. Then if you see text, which is again this one .io .text it should be, so you can actually import this one. Then for int writable, again org apache hadoop.io. So inside this io package you can see all these data types are there: int writable, long writable, and then text. Okay, so now we will be writing the map map class. So if you see public class map, then just a minute, this is saying like the type word count dot map. Yes, it has to implement the inherited abstract method, which is mapper method. Okay, now you can see it is extending to this MapReduce base, right? So whatever abstract methods are there, it has to implement them, and the method is this mapper public void mapper, and it will sorry, public void map. It will take same arguments basically. Okay, like input key data type, input value data type, then output key data type, output value data type. But at the same time, here we will be defining them as a variable. So we will be having a long writable variable, and I will name it as a key. Okay, so for map function, the first argument is a key which is of long writable data type. Okay, then the next argument is uh, a variable named value, which is having a data type text. Okay, then for the output we will be using a output collector, and it would be a text. So it would be a combination, right? You will be having several key value pairs, so kind of a repeated key value pair. So it's a collection, right? So it's output collector with text and int writable format. Okay, and that you will call as a output. That variable you can give name as a output, and then you can have an optional reporter class for kind of a if you wanna display anything like counter values and some reports basically for your MapReduce program, then you can use this reporter class, which should be part of. Okay, for output collector we can actually use this, and for reporter also we can use org apache hadoop mapread dot reporter. So this is it, and it can throws IO exception in case the anything goes wrong, like data type or anything. You can actually specify in an exception, so it will throw IO exception. Now here basically we inside the map class we are having this map method which we will implement, and this was the signature of that method. Now inside the map method we will be always write the business logic, and you guys know, I think, what is the business logic for our word count problem. Like we will be having a line, we will be splitting that line to number of words. Okay, and we will assign for each word a static value 1. Okay, that is our business logic. Okay, let me try to explain it to you in a simple way again. Let us say you are having a line like this: car, river, deer. This is your, you know, and let us say this is at 55th. So this is what key value pair. This is your key. This is your value, which is going to a map function. So what you need to do basically, from this value, okay, from this value, you will split them with white spaces. You will split this line to words using white spaces, and that is your business logic. Okay, so and that would be your key now. So now this is your key, and what would be the value? New value would be 1. Then if you see river, then comma 1. If you see deer, which is like this. So here business logic is what you need to basically split these lines to multiple words wherever any white space comes. Okay, and that would be your key. That would be your key now. Okay, so let us try to do this. So basically I will take, now we are writing Java code, right? So we have to because Hadoop is not having those splitting logic or something. You have to write the logic in Java, right? So I'm taking a string variable line, and whatever value is a variable, right? For you, if you see value is a variable that you need to convert into string. Why we are converting into string? Because value is a variable of type text, which is very much Hadoop specific data type. So Java cannot understand that. You have to convert into appropriate Java data type, which is nothing but string. So now line inside line I'm storing that value. Okay, so whatever value is there, that car space river space deer, that would be stored in this line variable. Now what you need to do, you need to split that line. So inside Java we are having some tokenizer functions which will try to split them. Tokenizer will split them with any white spaces. Okay, so I'm taking that string tokenizer class, string tokenizer, which is there in Java util. I'm creating an object for that. Tokenizer is equals to new string tokenizer, and I will pass that line over here. Okay, now you are having a tokenizer object. Okay, and this is a Java, so I have to end with a semicolon, and I will just write a loop while tokenizer, which is of string tokenizer type, dot has more tokens. So you have to write down a loop, and value dot set. Okay, now what would be the value, for the next time, the value would be the next token, right? So tokenizer dot get next token, that would be your value. Okay, so that like whatever is the next word, that would be going to that value. Okay, now you just need to set that output. Basically the output would be nothing but output key would be nothing but that value, right? So output dot collect, and you will pass the text, which is nothing but the value. So now value would act as a output key basically, right? And what would be the new value? So now for that key value, the value would be static 1, right? So we will not give simply 1, because 1 is again a Java specific integer. You have to convert it into Hadoop specific int writable, new int writable, and you can pass 1 over here. So I hope this is clear now. So what we did basically, we tried to use this tokenizer function. This entire line itself will actually divide that line into number of words, and that would be iterated multiple times in a while loop. until it is having more tokens, so till the last word, and that individual word would be collected as an output, okay, with a static 1 as a value. Okay, so that value would be key now and 1 would be the new value. So this way entire program works with that key value concept. Okay, and this is what we have written as a map class. Now we will write down the reduce logic, okay, in a reduce class. Okay, so basically, if we talk about reduce class, then again we have to define, right? Like what would be the input key value data type and output key value data type. So in the reduce, basically output of mapper would be there, right? And that would be sorting and sorted and shuffled. And that way, basically, whatever data types are there that are not going to change, right? It's just a sort and shuffle operation. So you got mapper output like this: deer comma 1, car comma 1, and river comma 1, right? So if you see, the reduce will have, and this would be given to the reduce function. And if you see, for reduce a function, the input key data type would be again as what was there in the case of mapper output, right? So that would be a reducer's input. So input key data type is text, and input value data type is nothing but int writable. Okay, and if you see reducer output, then it would be deer comma 1 1 1, something like this, right? And finally the summation. That means it would be text, output key value, output key data type is text, and output value is again again sort of integer only, right? And max, you it can go to long or long writable also, because sometimes the count is increased to integer limit, then you can actually provide the long as well. So let us try to define this thing in our program. So I'm having this mapper function which is now completed. So I will try to write down a reduce function which would be having somewhat same thing like public static reduce class, basically a reduce class which is extending to that MapReduce base, and it has to implement now a reducer interface which will take text, then int writable, right? Then output would be again like text, and I'm for simplicity I'm writing output value as also data type as a int writable, and that should be it. This is what our class looks like. Reducer interface, I have to import that package. Okay, and also the reduce, okay, is giving some error. Why? Because we have to implement the reduce function. So from the MapReduce base, if it is implementing the reducer interface, it has to like we did for map class map function, we have to give reduce function as well. And guys, you remember this thing, this is a class name capital MAP. Here this is a class name reduce. You can actually give a class name like map word count, something like this, then reduce word count. That is completely fine. Class name you can give anything. Okay, and even you can create a special Java file for this class as well, so that inside that Java file only this much code would be written. In complex programs, in big data, I have seen people are using different Java files so that the code is more manageable. Okay, and you are not exposing your business logic to the driver program. This is what driver program is, where you will write down the main method. Okay, so you can have a practice of creating separate Java files Okay, that is also fine. And inside the driver program also you can write down your map class, reduce class, but you can give any class name. But must remember this, any class name which has to extend to this MapReduce base and implement the mapper interface. And this particular method should be map only, and here whatever we are going to define, that should be reduce only. You have to remember that thing. I hope the basics of Java concepts these are, so not a big deal. So I'm creating a variable key which is of type text, and now I'm creating a iterator. Basically, why a iterator? Because in reducer, basically all the values, keys would be same, right, and values would be repeating. So I'm creating an iterator of iteratable because it is having a static one, and that would be my values. So for reducer, if I tell you in this particular way, like for reducer, your key would be same key, but values would be kind of an array. Values would be 1 comma 1 comma 1. Okay, same key, multiple values, and for on this it is going to apply the sum function or max function, min function, anything. Okay, so So these would be the values, and then again, like what we were having, output collector, which is having again key value data type. So we will pass text as a key now, and int only would be the value. And this would be called as output, let us say. And the the fourth, one, two, three, four, yeah, fifth argument would be the reporter class, reporter, and we will give the object name as also reporter. That's fine. And iterator, so iterator I'm using java.util. Okay, and this should be it. Now, yeah, again, I can actually throw an exception, throws IO exception, that is also there. Okay, now inside this, basically, I have to write down the reducer logic, which is starting with a variable sum, which is refined as a 0. And then later on, you can simply have a while loop, okay, to iterate through these iterator values. So while values dot has next, okay, and we will just iterate through that values iterator, and we will take one value each time and dump into the sum is equals to sum plus values dot next. Okay, values dot next means the next value, and again you have to use a get method to get it in int. And so guys, you can see sum is of int data type, which is different than the iterable of Hadoop. This is Java specific data type. Okay, and finally, once you get the sum, what you need to give in the output, which is a output collector object, output dot collect, and you will pass a particular key which would be same, which would be nothing but the key only which was there over here, but the value would be now sum. Okay, and sum is again int, so you have to convert it into int writable. Okay, so that sum variable is holding sum of all the values in this values iterator, and that is going to be int of Java. We are converting into Hadoop specific int writable, and this should be it. This is your reducer class. Okay, now what we are left with the main method. Okay, so that is something you can define like this: public static void main, and it will take some args of a string array for arguments, and it can throws exception as well. Inside the main method, basically you will pass the job conf parameter, like job conf is a class. Okay, configuration related things is equals to new job conf, job conf, which is org Hadoop, org Apache Hadoop MapReduce.jobconf. Inside the job conf, you can actually pass the class name, which is word count dot class. Okay, so that is the first thing, like which is the class which is referring to this job conf. Okay, and that is word count, in which we have written all these things. Now you are having this conf object. You can actually set all the parameters using the conf object. Conf dot set job name, to set the job name, which would be appearing as a resource manager in the resource manager URL. And you can pass any particular name for your application, word count demo, that is your application name or job name. You can pass the input format, like conf dot set input format. Input is text input format for us as of now, so text input format dot class, that is again a class. Then conf dot set output format, which would be again text output format, text output format dot class. Okay, then you can specify the mapper class. Okay, which class is going to act as a mapper class. So that's why I told you it's not specific, like you have to give a name, something like this. You can give any name, but at the end, in the main method, you have to create a job conf object, and inside the conf object, through which you can specify which class would act as a mapper class. Okay, so conf dot set map class, uh, set mapper class, and you can specify the class name. And in our code, MapWC is the class for the mapper logic. Then conf dot set reducer class, and reduce WC, reduce WC dot class would be your reducer class. Then you have to specify the input format, output format we did, right? And job name we did, mapper class we did, and then you have to specify the output key class and output value class. Okay, so that also you can specify like this: conf dot set output key class. That would be text, right? Yeah, your output is nothing but of text data type or text class. And conf dot set output value class is int-writable dot class. Okay, so I think we are done with the configuration related things. Now you just need to give the input path and output path. Okay, so file input format, dot set, it is having a method called set input path, set input paths. So you have to pass the input path. First one is the configuration object, and then the argument. So basically we are not going to pass statically over here in the program. You can do that as well, but we are going to run a Hadoop jar file, right? So at that time we will pass the input path and output path as an argument, and that is the reason string args is there, right? So that args of 0, that means the first argument would be nothing but the input path. So args is an array index start with 0, so args of 0 would be acting as a input path. People who are very familiar with Java command line thing, they would be easily getting what I'm talking about. So arguments of 0, args array of 0th element would be acting as an input path, but that is a string, right? You have to convert it into again a path variable. So new path, and I'll just create the path array like this. and this path class you have to define as a org apache hadoop fs, because this is a hdfs related thing, right? So path is a class purely related to hdfs. File output format dot set output path, and you can specify the job conf object over here as well, and the argument one would act as a that means the second argument, index number one of args array would act as a this thing output path. Okay, so this is what we will be having. File output format dot set output path conf new path args of 1. So finally, we are setting the output path as the index number one argument from that args array. And a last line which we have to write is job client, which is kind of a client object. And it is having a run job method, which will take the configuration object as a argument. So this is the line basically to submit a job, by the client mode. So if you are writing everything, but if you are not writing this single line, your job would not be submitted to the resource manager. We have seen in the last module, right? Like how Yarn is managing all the application. A client has to submit an application, then only the resource manager can allocate the resources and all. So this is the line which is going to submit your job or running the job with conf as an argument. So conf is actually a driving factor. Conf is kind of a job conf object which is having all the things like which is the job name, okay, which is the mapper class, which is the reducer class. So framework will automatically see and form a picture like main is your starting point, right? Main method. So it will start with this a conf object, then when it encounters this line it will go a reverse tracking, and then it will go to the mapwc class. It will do sort and shuffle, and it will do reduce. It will go to reduce wc class and perform the reducer operation, and then the set input path and set output path will also build the context, like from where the data should be read and where you have to write the data. So that way the entire word count program we have written, and this is the way you have to perform various other programs as well in terms of key value pairs. What would be the data type of key value pair? The skeleton is fixed, right? Like we have to write down the mapper class, reducer class. Inside the class you have to implement the map method and reduce method, and then you have to write down the business logic in map method, and you have to write down the aggregation logic into the reduce method. So this skeleton is fixed, but the data types would change from program to program, and the business logic would change how you perform the uh, you know uh, uh, splitting logic, how you do all these things. That would be purely your call, but this is the skeleton for standard word count or standard map reduce program. Now we will try to run the same. To run that, we have to export or deploy this program as a jar file. Now we will do that.
So guys, now we have this Java file ready. Let us try to deploy or export to the jar file, which we can run anywhere. So project, right click, export inside the Java jar file, next, and then we can browse to which particular folder we want to save the jar file. We can try to save it to maybe inside root home Cloudera. There can be a desktop, and on desktop I'm saving it as Hadoop mr word count dot jar. Okay, next And next you have to select the main class from here. So our main class is there in this word count class only, right, which is in the test mr demo package. So that you can select. If you are having mapper reducer in different classes, as I have already told you, then you can actually get multiple classes over here, and whichever is having main method you can select it. And sometimes it may happen you may have multiple driver classes also in the same jar file. So at that time also you can select the main class method, or main class or a class which contains the main method from the drop down list. And if you forgot to select from here, you can do that programmatically also whenever you are running the Hadoop jar command. Finish. And now if you go to desktop, you can see Hadoop mrwc.jar file is there with you. Now we simply need to run this particular jar file. To do that, the command is Hadoop jar. But before doing that, let us try to set up the input data. So I'm having in the home folder, there is a input data folder, and let us try to get the input data wc input. Okay, I already have this file. If I just show it to you, this is my file which I want to process. So I need to upload this file to HDFS. So let us first do that. For that, the command is hdfs dfs hyphen put, and on HDFS, let us see where we can put the file. Let us open the HDFS filing structure, root user Cloudera. Yes, here in input data HDFS probably you can put. So wc input.txt I want to put to input data HDFS folder. Yes, I do have my file with me. So I simply need to run now Hadoop space jar file path, which is there at desktop, Hadoop mrwc.jar. Then I can simply go to input data hdfs slash wc input.txt, and then output folder. Output folder I'm giving as mr output. Okay, so basically it will create a folder for you. Inside this folder, all the MapReduce related output would be stored in terms of part files. Let us see that. I'm just running this particular command. So this will invoke a MapReduce job basically. So here the input path which we have given, which will be args of 0. This is args of 1, which we have specified in our program. If you see, args of 0 is your set input path. Args of 1 is your output path. And you can see map 0%, reduce 0%. That means the MapReduce job is invoked. If you want to really see the resource manager, I can just show it to you. This is the URL in your Firefox or browser. You just open the resource manager URL, and you can see the running applications, and there is an application ID which is running, which is having a type MapReduce, and word count demo is the name. Remember, you had set this word count demo
as a job name. So that is what appearing over here. And yeah, this is the tracking URL, application master. So you can relate all the things which we have studied, like yarn demo, or in our last session which was about yarn daemon. Okay, so you can see there are two maps, there is one reducer. Okay, and all of them are successful, and you can see the job is completed. It will show some counter value. There are 49 counters which are divided into different categories: file system counters, job counters, MapReduce framework. So in the file system counters, you can see number of bytes read, number of bytes written. Okay, all the things related to the HDFS or local file level operations, or distributed file level operations which it has performed. Then number of write operations is 2, number of read operations is equals to 9. Then job counter, like launched map task, is equals to 2. So it has launched 2 map tasks. It would be completely framework decision. Launched reduced task is equals to 1. You can set the reduced task also. Right now it has taken one reduced task. Okay, but you can configure it in your program also. Then if you see MapReduce framework, then map input records were 3, right? Like in that WC input file, there were 3 input record which was sent to map. So map input records are 3 and map output records are 9. That means it has divided these particular 3 lines to number of words, and total 9 words are there in the output. So that is one thing. Then reduce input groups is equals to 4. That means if you see 4 distinct keys would be there, 4 distinct words are there, like deer, bear, and river, and car. So these are the 4 input groups which are given to reducer. So that is one thing. Reduce input records is equals to 9. Reduce output records is equals to 4. Total records were 9, but groups, if you see, 4. And output record would also be 4. So this way, basically, all the statistics around your MapReduce job would be shown over here as a counter value. Now let us see the output of our MapReduce job. We can simply go to root user Cloudera. Here MR output is a folder. Here we are having a part file. Basically, if you see, there is a part file. If you open this part file and download, this is the part file, and open. So you can see bear tab 2. Tab is the default delimiter for MapReduce job. Then cars tab 3, deer tab 2, river tab 2. So this way, basically, you got counting of each word, and this is what our expected output was. Okay, but it will come in terms of part file, because MapReduce program generates always the part file only. Okay, always a MapReduce job result would be a part file, and you can't actually give the same command again with the same folder name mr output, because it will say like the folder directory already exists. So you just need to give a different name or just delete this part file. Okay, so that is how MapReduce job works. We have seen a live practical demo of word count program implementation using MapReduce. Now we will quickly understand partitioner and combiner concept, and we will implement the same using the Java programming language. So let us move to the next topic, which is partitioner and combiner. So basically, partitioner in the MapReduce programming framework, it is working like a condition in processing an input data set. So partition phase always takes place after the mapper phase. So we know, right, like there is a input split happening, after which we are having a mapper, and then mapper is having some logic, business logic. It will split into key value pairs, and then sorting and shuffling phase would take place, and then the reducer phase will come. So partitioner is coming here in between, your mapper and reducer, and it is also known as customized shuffler. So by default, if you are not writing any partitioner, then MapReduce framework will anyhow sort and shuffle the data like we have seen in our demo also. But here it is kind of customizing that shuffling task, and number of partitioner is equals to number of reducer task. So in a way, we are basically specifying, which data set should go to which reducer. Rather than framework deciding that, we are actually giving that using our program. So you basically divide the data according to number of reducers. Data passed from a single partitioner is processed by a single reducer. So let us say a partitioner number 1, which will go to reducer number 1. Partitioner number 2, which will go to reducer number 2, likewise. So at the end, you will get, number of reducers is equal to number of partitioners. So partitioner will partition the key value pair of the intermediate map output. So definitely it will take output from mapper. And partitions, partitioner will partition the data according to a user defined condition which you will give in your program, which will act just like a hash function. Okay. Then your shuffler, sorting and shuffling, in that the shuffler is there, right? It is nothing but a built-in feature of the framework, and it is also working based on the hash key function only. But this one is something very customized. You will give the condition, and on that condition it will partition and allocate the reducer for it. So it is a replacement of the built-in shuffler. Now if you are not writing anything about partitioner in your job conf, then definitely by default it will call the built-in shuffler only. If you are coding your partitioner in your code, basically, right, then custom shuffler, that means the partitioner logic only would be implemented, and the built-in shuffler will not be called by the framework. Okay, so you basically have to write a partitioner class. Inside that partitioner class, you will write down some logic, and that logic would be implemented to allocate the reducers. So we will see that how it works. So this is a simple program with partitioner. So here you can see the class is with partitioner. The change you will see over here is in the main method in the job conf dot along with set mapper class, set reducer class, I am calling a set partitioner class as well. This is where the difference is. So in the set partitioner class, you can see my partitioner dot class is getting executed, and there is a class basically which is my partitioner. You can have it as in a separate file as well, but as of now, for simplicity, I have put everything in this file only. So my partitioner class, which implements the partitioner interface with text and int writable. Remember, your mapper is having a same argument. So mapper output would be text int, right? Like car, comma 3. Car, comma 1, river, comma 1, like that. So here also it will take the same argument, right? Then there is a get partition method which you need to implement, which will take text type variable key, int writable variable value, and int num partition. This num partition is something, number of partitions which you are specifying. So there is a key which is of text data type, we are converting into string and making into lowercase, and we will just see whether it is car or river. My key dot equals car and my key dot equals river, then you will return 0. If my key dot equals deer, then you will return 1. Okay, else you will return 2. That means you are actually specifying 3 return values. Right, you are specifying 3 return values. So in a way, car and river, those would be processed by one reducer. Dear key would be processed by one reducer, and all other things would be processed by another reducer. What is the advantage of this? Like, a single reducer is not overburdened. In your program to find number of occurrence of a word, some specific word would occur multiple times, then you can actually assign a specific reducer for that, so that that reducer will process that particular big word or a word with higher occurrences. And all the small words which are having a low occurrence, okay, then you can specify them to processed by one reducer. So basically you are actually driving this decision which key will go to which reducer, like this. Okay, so there is a conf.set num reduce task that also you have to specify, which is 3, which is forcing the program to run on 3 reducers. Okay, so this is the program. Let us simply run this file onto Eclipse. But before that, I want to cover one more concept, which is combiner. Okay, so combiner is also very important, and we will run the program with partitioner and combiner all together in one go. So let us study the combiner concept. So combiner basically concept came which is acting like a local reducer. Basically, combiner is also known as local reducer. So very large data set, if you see, the flow is like this, right? Like mapper output would be actually traversed in network, all those key value pairs, and then reducers would aggregate. So this intermediate data which is generated by mapper, that is actually getting passed to the reducer, and it may happen. This is a very big data, right? So network congestion may happen. But combiner, which is known as local reducer or also known as semi-reducer, what it is doing, it is an optional class which will accept the input of the map class and then passing the key value pairs to the reducer class, but in between it will summarize the map output records with the same key. That means whatever reducer is doing, it is doing the same thing, right? It is aggregating based on the same key. Okay, so here the advantage is combiner is doing at a local mapper level only. Let us say you are having a map 1, you are having a map 2, then it is the map 1 machine itself is doing some local level aggregation for that particular mapper. Whatever key value pairs are there it is aggregating based on the same key and based on the same key and aggregating the values and then generating one final set. Okay, I'll show you the example how it is working. So in our general flow, what happens, like car, river, deer, bear, car, river, bear, deer, car. What mapper 1 is doing, like car, comma 1, river, comma 1, deer, comma 1, right? That is the first line. And mapper 2, that is the second line. It will do bear, comma 1, car, comma 1, river, comma 1, bear, comma 1, deer, comma 1, car, comma 1. Total 10 keys are there, which are intermediate data. And finally, without combiner, when you see, it is transferring these all 10 keys, and then reducer will actually, what it will do? It will simply combine based on the same keys because all the keys are there with it. Okay, so final output is something like this, right? Like car, comma 1 1 1 1, that means summation of 1 is 4, summation of 4 times 1 is 4, then river, comma 2, deer, comma 2, and bear, comma 2. So there are total 4 keys in your output. This is without combiner, our standard classic flow. Now with combiner, the mapper 1 and mapper 2 both will run a semi reducer on their machine itself, on their local machine. That means car comma 1, car comma 1, river comma 1, deer comma 1. Like for these 4 key, it will perform the reducer or semi reducing task, and it will do car comma 2, river comma 1, deer comma 1. So, and then shuffling and sorting, all those things. And here mapper 2 would also do the same, bear comma 2, river comma 1, deer comma 1, and car comma 2. Now if you see three key value from this and 4 key values from this, total 7 keys only would be transferred to the network. And then based on this total 7 keys, reducer, what it will do, it will have car comma 2 as an input, and here from here also car comma 2. Okay, so car comma 2 comma 2, rather than 1 1 1 1, it is getting 2 2, and final output is same only, right, because it has to aggregate. But here the semi reducer task, that means the local level of aggregation is already performed, so lesser number of keys are actually getting transferred to the network. This is the advantage. In a very big data scenario, you will have so many key value pairs, and this is what will help you to transfer the less data to network. So advantage is like Hadoop combiner will lower the time taken for data transfer between mapper and reducer. And definitely the amount of data is less which is required to be processed by a reducer, and the combiner is totally improving this overall performance of the reducer as well. And disadvantages are also there, like MapReduce jobs cannot depend on the Hadoop combiner execution, as there is no guarantee in its execution, right? If any mapper fails, then definitely you are not having a local aggregation happened at that level, which can actually be a risk. And in the local file system, the key value pairs are stored in the Hadoop, and the combiner is run later, which which will cause expensive disk input output as well. Okay, so those are the shortcomings of using combiner. Let us try to use the combiner and perform the word count program. Okay, so partitioner and combiner, both you can implement in the same program basically. I'll show you the code, and then we will run the same on Eclipse. And to specify the combiner, you just need to give the same reducer class, but in conf.setCombiner class method. Okay, so conf.setCombiner class, and you will specify the same reducer class, nothing else. Okay, this is the only line which will make sure the combiner is executed. That means the local level of aggregation by the mapper machines only would be performed. Okay, and then set reducer class is also there, okay, which is also reduce.class. So your reducer class would be argument to both the methods, set combiner class and set reducer class. Nothing major change. I'm just copying this program as of now, and let us try to create a class in our test MR demo. With partitioner and MR demo. So yeah, these are the this is the code which is there. So here this set combiner class for combiner, then for partitioner set num reduce tasks to 3, which will ensure 3 reducers are called, and set partitioner class to my partitioner class, and one additional code for my partitioner. Let us try to now export this particular one again to create the jar file. I'm giving PC partitioner combiner, next, and main class, you can see now two classes are appearing, right? So you have to select which main class you want to run. We want to run with partitioner's main class, so that is something which we need to specify. And you should see in your desktop there is a Hadoop MRWC PC.jar which we want to run. So Hadoop MRWC-PC.jar, that would be my jar file. Same input path and output path, we need to give something like this, mr output-pc, because it's a different file which we need to process different method. So I'm giving a different output folder. So it will run again a MapReduce job. It is running a job which you can see in the resource manager as well. Running applications. Yes. Name of the application is word count. Correct. And tracking URL, which is application master URL. So this is the application ID, which is unique for each and every application. Yeah, it's running. And here you can see reducers are 3 because we have specified you have to invoke 3 reducers, right? And mappers are also 2. So map 0%, reduce 0%, map 100%, reduce 0%. That means the mapper is completed now. Now it is running the reducer. And here if you see, map input records are 3, output records are 9, and reducer input group, all those things would be same only, right? But the number of map task is 2 and the reduce task is 3. Okay, and now the strange thing, or a very obvious thing which you will see in the output folder, which is mr output pc for partitioner combiner, you will see 3 part files. And the reason behind this is number of part files, which directly indicates number of reducers. Basically 3 reducers were invoked and each reducer will submit its output, right? So there would be 3 part files over here. Okay, and if you see part file number 0, then part file 1 will just download, and then I'll show you like different keys would be processed by each one of them. Okay, and show all downloads. This is a downloads directory. So car and river, only 2 key value pairs are there in the part file 0. Part file 1, deer comma 2, that means the deer is the second key value pair. Okay, and the third one is bear. Okay, so this is what we had specified, right? We had specified like car and river should go to 1 reducer, deer should go to 1 reducer, and rest of the all keys would go to another reducer, which is only bear in our bear in our case. So there were only 4 key value pairs. 2 are processed by 1 reducer. Second, the key which is deer, and then bear. So this way basically it has grouped, or it has divided all the key value pairs to different reducers. So guys, we have actually completed this module. Let us have a quick recap of what we have achieved. So we tried to implement the classic word count problem using Java MapReduce. We performed the practical on Eclipse. We understood the partitioner concept, we understood the combiner concept, and the same word count problem, including partitioner and combiner classes, for word count, we have implemented the Java code, and then we ran the same, and we saw like number of reducers are getting changed, and so as the part files which are generated after the MapReduce job. So thank you very much. Don't forget to like and subscribe.